Okay. All right. So going to start tonight off. We're just going to keep moving along. Um, okay. We've got a free response question. This is from 2018, and this is the actual question that people did. So a lot of what we're going to be doing here down the stretch of the next month is I am just going to go through with you guys everything that the kids did over the last 2, 3 years. So here it is. This is 2018, number 4. We're going to do it in about 10 minutes or so of your own time, and then we'll talk. So I'm not going to say anything. I will tell you that part D is a related rate problem. We should be able to get through A, B, and C with not much difficulty. And part D is a related rate. So think about what it means to solve a related rate. It is 7:04. We will talk at 7:15. Ready, go. Okay, let's see what we got. Letter A. Anybody want to share with me what they got?
I got 2 meters per year.
How did we get that? So what are we writing? H prime of 6 is approximately equal to what?
6 minus 2 over 5 minus 3.
Now, hang on. We want H prime of 6. Remember, that's an X value of 6. X values are up here. So where is the 6 going to be? It's going to be between 5 and 7. When they're asking you for H prime of 6, they're looking, that's the X value being 6. So you're approximating between 5 and 7. So we want to go with not quite what you said, a little bit to the right. Does it make sense to say 11 minus 6 over 7 minus 5? So that would be 5 over 2. And then what do we got there? Meters per year squared. Does that make sense?
Yep.
Okay. All right, somebody else, letter B. Explain why there must be a time from 2 to t to 10 such that h prime of t is equal to 2. Okay, so this is a little twist on a problem we already know. What type of problem is this?
Is it find the slope or
Mean value theorem, is that what you're saying? I think I heard somebody say mean value theorem. So
yeah, I said that.
okay, so first off, the answer is yes. So there must be a time on 2 to t to 10 where basically we're just rewriting the question, right? Where h prime of t is equal to 2 because, what's our because? Because the function is differentiable and therefore continuous by the mean value theorem. All right, what about the mean value theorem? What do we know about the mean value theorem? We're looking for a slope to be 2. Now, prior to this, I had told you guys to just go to the endpoints, and that's usually where it's at. And that's like 99% of the time a true story, other than this problem. So if we go to just between 2 and 10, 15 minus 1.5 over 10 minus 2, that doesn't do it for us. So we need to go somewhere else. Where's the somewhere else? We need to find an interval in that range that gives us 2. And that range is right here, from 3, 5, 2, and 6. If we take those ones, because 6 minus 2 over 5 minus 3 gives us 2. Does anybody have any questions on that one?
So you kind of have to go through it a little bit.
This is the only one where I've seen that you got to go through it. Every other mean value theorem question in the history of College Board, the endpoints always takes care of it for you. This was the first time they ever did that. So apparently it's possible.
Mr.
Just-
Baker,
Yes.
for the second part of question, the first question, it says interpret the meaning of the hold on, I cannot see it. Of h prime of 6 in the context of this problem. So
Yeah, they might want us to do a little more than now that you point that out. Interpret the meaning that's going to be the rate at which the tree is growing at t equals 6. That's approximating it.
okay, that's what I put. Just wanted to
That
confirm.
I said the rate at which the tree grew between 5 and t and 7 years. I don't know if that works.
Yeah, I think that works too. I mean, because it's all still an approximation. I think they would give you credit for both of those.
Okay, got it.
Okay, part C should be friendly enough. That's just doing a bunch of math, not even doing it, just writing it down. So the first thing you want to do, guys, you got to lead with the integral. The integral from 2 to 10 of h of t dt is approximately equal to, and then I'm just doing bracket, and we're going to just set up the math for each one of them. So it's going to be, how do we do area of a trapezoid? Base 1 plus base 2. So 1.5 plus 2, cut it in half, times the height. So that's the first one. And then we just keep going, and you would do that 3 more times. So I'm not going to write all of that out, but you would just do plus, and then do another one, and plus, do another one, and then you got it after that, okay? Any questions on C? Okay, takes us to D. All right, so we've got lots of things happening here. It's a related rates question. Now, we can make this, there's no way that this is going to be an easy question, but we could make it way more manageable than what it appears to be. And that's just by going slow and not getting overwhelmed by the 5,000 words here. You recognize it's a related rates question. So what's the first thing we do in a related rates question? We need to find an equation. Okay, they gave us one. So let's just take the derivative of that and pause, because you know to do a related rate, we find an equation, we take its derivative. To take that derivative, you need a quotient rule. So the derivative is going to be, remember, all variables derived get a d whatever dt. So dg dt is equal to, now we're going to crank out a quotient rule. And that quotient rule would be bottom, derive the top, 100 dx dt, bottom derive the top minus the top, derive the bottom, just dx dt, over the bottom squared. Okay, now the next step in a related rate is to go list our variables, and then we'll go hunt for what we know and what we need. So what do we have off to the side in our box? We have dg dt, we have x, we have dx dt. Okay, so with that in mind, we need to go figure out what they're asking for, is what I always like to find. So I go to the end of the question. What are they asking for? According to the model, what is the rate of change? So that's going to be a d something dt, rate of change of the height of the tree. Okay, what do we know up here? The height of the tree is modeled by g. So the rate of change of the height, they're asking you to find dg dt. Okay, so now your objective is figure out x and dx dt, either from the problem or something, and then you just plug stuff in and you got it. So what do they tell me? When the tree is 50 meters tall, the diameter of the base of the tree is increasing at 0.03. That's the dx dt. dx dt is 0.03. Okay, now when the tree is 50 meters, we got to go figure out x. They don't tell you x. It says when the tree is 50 meters. The height of the tree is modeled by g. So to figure out x, you got to plug in 50 for g of x, make this a 50, and solve it out and see what you get. Because this whole thing is happening when the tree is 50 meters. It's changing at 0.03 when it's 50 meters. So to find x, you want to go up to that equation and you plug in 50. So if we plug in 50 and do some algebra, 50 is equal to 100x over 1 plus x. Solve that out. Pretend it's 50 over 1. Fraction equals fraction. How do you solve that? The algebra says to cross multiply. So that's 50 times 1 plus x is equal to 100x. Distribute. 50 plus 50x is equal to 100x. Subtract 50x. 50 equals 50x. X is equal to 1. Okay, you're home free, guys. You don't have to do any math whatsoever. You just go over here. It's free response. Just plug stuff in and leave it. So dg dt is equal to 1 plus 1 times 100 times 0.03 minus 100 times 1 times 0.03 all over 1 plus 1 squared. You got full credit. What do we think? So when you see a related rate, don't freak out. Just go slow. You got tons of time to get it done. Remember the steps of a related rate. Just go through it and see how you do. Any questions on that? Okay, give me 1 second. We'll go back over and we'll get you another one to go through. Okay, guys, this is number 6 from the same test. This was number 6 from 2018. Same deal. Let's take about 10 minutes or so and we will talk. You probably want to focus on parts B and C. I would assume you're going to have a little bit of difficulty with part A just because we haven't really talked about that yet. Okay, so take 10 minutes and we will talk. Okay, let's see what we got. So first part, we gotta look at, it's super easy. We just haven't looked at it yet. Okay, a slope field is given. Sketch the solution curves. All they're really doing is saying that all of those little marks stand for the slopes of lines at particular points. And if you're going to sketch the solution curve, you just follow the line. So there should be a line going horizontally right here at 2. So at 2, you would have a line going bold this way. And it also wants us to do the solution curve at 1, 0. So I can't draw this exactly, but you basically want to follow those slopes and you would get something that looks like that. So if you would follow, just kind of connect the dots, basically, you would just highlight those 2 areas that I have right there. Okay, that's really all they're asking for. Okay, letter B. We want to find the tangent line. So first off, it's the tangent line at 1, 0. So for part B, we want to make a box, and in my box is going to be a point and a slope, and then the point is going to be 1, 0. And then how do we find our slope? Well, we plug this into dy dx. So if we put 1, 0 into dy dx, that's a third times, what do we get over here? That's 0 minus 2 is -2, squared is 4. That's 4 times a third. I'm getting 4/3 for my slope. And then this would be y minus nothing is equal to 4/3 x minus 1. And they ask you to use that equation to approximate 0.7. So this would be y is equal to 4/3 times 0.7 minus 1. Y is equal to 4/3 times, that's -0.3, also known as -3/10. If you were to do that math, that's -12/30. That's really -2/5. Any questions on part B? Okay, part C is your differential equation. So somebody out there, tell me, what'd you get for C, the value C? Anybody?
Yeah, I didn't get it well.
Anybody out there get something for C?
I'm kind of stuck with the y integral. It's just
All right, well, tell me how you split these up. So tell me, at least start me off. What do we do here?
okay. So I cross multiplied first, so I got 3 dy, and then
We got to get the y's on the left, right?
yeah. Okay.
Just think of it as the,
Yeah. How about multiply both sides by 1/y
and
minus 2?
that sounds better. So we got 1/y squared, or I'm sorry, 1/y minus 2 squared dy is equal to 1/3 x dx. Does that make sense?
Yes.
Okay. All right, what do we do from there?
Okay, so we take integrals from both sides and
Okay, so we're going to integrate. Okay. Left side, what are we doing?
use substitution.
Okay, so that's going to be u du dy. So that's y minus 2 dy du. Still good?
Yeah. Oh, actually, I expanded y -2, and that got me wrong. but this sounds better, yeah.
Okay. All right. Now to integrate on the left side, are we able to do that yet, or do we need to flip that up?
Yeah, we have to like flip it upstairs.
Okay. So that's u to the negative 2 du is equal to 1/3 x dx. All right, finally, you're ready to integrate all that. So what do we get if we integrate on the left?
Yeah, u to the negative 1 over
Good with u to the negative 1 over negative 1? I think you cut out there. Hopefully that makes sense. So when we clean this up, this would be negative 1 over u is equal to x squared over 6 plus c. Putting our u back in, negative 1 over y minus 2 equals x squared over 6 plus c. Do we have any questions up to that point? Okay, plug in your point. Your point was 0, 1. So if you plug in your point, it's going to be 0 for y. So that's negative 1 over negative 2. So that's a half is equal to a 6 plus c. Giving this a common denominator, we can make this 3 over 6. When I subtract 1 over 6, so this would be 3 over 6 is equal to 1 over 6 plus c. Subtract 1 over 6, that gives us 2 over 6, and 2 over 6 is a third. So now we know that c is equal to 1/3. Plugging that back in, we've got negative 1 over y minus 2 is equal to x squared over 6 plus 1/3. I'm going to call it 2/6 instead of 1/3, just so that I can common denominator this. There's a lot of ways to express this here, and all the ways that are equivalent would get you credit. So now, which of our ending scenarios are we on here? This is the one where we want to turn both fractions upside down. So this would really be y minus 2 is equal to x squared plus 2 over 6. And then we got to add the 2 over to this. And does that check out, guys? Negative 6. So we had a negative 1 on the bottom. That's it. You got it. Do we have any questions? You guys are being super quiet.
How'd you do that again? Of the last part?
I'm ready. Just turn them both upside down.
What was the point again that we had to plug in? Sorry, I missed that.
C, the point is 1, 0.
Okay, thank you.
Mm-hmm. Any other questions, guys? Okay, we'll stop there for tonight. We'll do the same thing this week on Tuesday, Wednesday, Thursday. We'll be going over questions. So try your best to make it. Try your best to keep coming. We're on the home stretch. You're down to like 3-4 weeks to go here. So try your best to stick it out. You've come this far. I know it's getting tough to stay focused and get all of this, but it's only one more month. It's only a handful of classes online, and then you're all done with calc. So try your best to keep coming and ride this out so we can hopefully pass the AP exam, and then you're all done. Okay. So I will see you guys tomorrow night at 7 o'clock.
Thank you, Mr. Baker.
All right. You got it. See ya.
Mr. Baker, this is more of a personal question, so if anybody else wants to go first, that's totally fine. But I was thinking about do like which date to do the AP exam on, and I'm thinking about doing it on the 9th, but I have the AP physics exam that day, and I'm just wondering if you recommend doing that,
Mm,
like taking the AP exam, because I have my physics one in the afternoon, and I'm wondering if you recommend taking 2 in one day or just doing it separately.
I mean, I don't think there's a right or a wrong answer to that. I mean, I don't know. I mean, I know of lots of kids every year that take 2 of them in one day. It's possible. I mean, it's certainly not impossible. I guess, I mean, if you have your, it depends on if you're comfortable coming to school. If that's going to make you uncomfortable, then there's no point even thinking about it, because then you're just not going to be comfortable at all. If you're comfortable coming to school, I mean, I think you're better off taking 1 of them at a time than 2 in a day, because that's like basically 8 hours of math back to back.
Right. And
Which
I
is,
think because I'm like, I think is the calc one, is that at 8 a.m. or 12
I
p.m.?
believe we're 8 a.m.
Okay, actually that might work then, because I have the physics one at 4 p.m. So I'm not sure. I'm not sure yet. We'll see. I just wanted to see what you recommended or get an idea.
Yeah, I mean, it's more so what you think. I mean, if you can, when is the physics one? Is it on June 9th or on
It's on June 9th. It's like 4 p.m. June 9th. Yeah.
Gotcha. Let me see here. Do I have? Let me see if I have. Yeah, it looks like it's, well, no, that's the thing you sent me. Let me see here. According to the Google Doc, it's June 9th at 12 p.m.
Okay, that's what I feel like that's what I saw.
Or May 24th at 8 a.m.
Okay.
So
Then I would definitely be doing 8 hours back or like.
yeah, you would pretty much be going from like noon till like 7 p.m. They're doing math.
We'll see. I have to decide. I mean, that's what I did. Like, I mean, on those Tuesdays where we had those like tests, I would do like physics and exam for like that hour and then go straight to calc. I mean, it's not impossible. I just have to decide if I want to do it or not. So.
Yeah, it's definitely not impossible. I think it's just a matter of what you want to do and where you feel most comfortable.
Okay, I'll think about it, but thank you.
Okay, you're welcome. See ya.